least I hope he'll be back soon. Oh, we have 2 Chris Vaughns now.
Oh, do we?
We do. I'm going to kick the old one out, I suppose. Let's see. All right, we're now up on YouTube. Oh no, wait, yes. Okay, I'm going to kick the old you out. Okay, Chris?
Okay.
Oh, the old you left anyway.
Yeah, it crashed on me again.
Okay, you're back now anyway. So we're doing a little bit of technical troubleshooting as we go. Welcome everybody. Hi everyone who's joining from all over the place. For those of you who are joining for the first time and haven't heard me give this spiel a million times, if you would like to talk to everyone and not just Chris and I, please do change the little blue bar in your chat window from all panelists to all panelists and attendees. And I say it's blue, and I realize this may not be blue for everyone, so it might be white. But no matter what, change it to all panelists and attendees so that you can talk to everyone who's here. We've got about 70 folks here now. And so far we only have one Chris Vaughn, which is, I think, good for now. We may end up with multiples, we will see.
All right, let me share my screen then. Here we go.
Yeah, we'll get started. I'm gonna, before we actually, can I ask a question before we get started? Can I run a poll to see how you guys are all doing? Some of you may have heard of Comet Neowise. And so I'm going to run a poll to see how many of you have seen it or even know what it is, or don't know what it is. So please do vote to see if you've seen it yet or if you have not. While you are voting, we're just going to talk a little bit, while we're going to tour the summer Milky Way today, we are going to talk a little bit about Comet Neowise because it is the most interesting thing happening in the world of visual astronomy right now. And everyone's really excited to be seeing a comet again. All right, I'm going to give you guys 5 more seconds to vote. Oh no, so many clouds. Yeah, sorry, Kareem. It's been cloudy in a lot of places lately. Either cloudy or blindingly hot. Alrighty, I'm gonna end that poll. We only have 2 people who don't know what it is, so don't worry, you're gonna find out soon. A lot of folks who have not seen it yet, only 5 who've seen it in the evening and 4 who've seen it in the morning. Those of you who in the morning are very, very dedicated. I'm getting up early to go out and see that comet. Not everyone will. There are the results for everyone who wants to see it. I am certainly, I don't know about you, Chris, but I am certainly an evening astronomer.
Me too. So last night was my first attempt. All right, let me give you just a couple minutes quick recap on Comet Neowise, and then we'll move into our prime topic for the day of the summer Milky Way. So let me just share my screen here. So first of all, why is it called Comet Neowise? You might have seen C/2020 F3, and it's actually pretty simple when you break it down. So Neowise is the space telescope that first discovered the comet. It was actually the WISE Wide Field Infrared Survey Experiment telescope that was designed to look for Kuiper belt objects, things that are trucking around inside the solar system. And it works in infrared, so it needs to be cooled down. And when it lost its cooling, it ended its mission and it got reborn as Neowise. Neo for new and Neo for near Earth object. And now it looks for near Earth asteroids. And so it has a big wide field camera that sweeps across the sky, and every 6 months it records the whole sky from the orbit of Earth. And it looks for things that are moving, and Comet Neowise was moving through it. So that's where the Neowise comes from. The C stands for comet. And if it turned out that this comet was periodic, like Halley's Comet, where it would return on a regular cycle, that C would become a P. But right now, this comet, I think it has a period of maybe 6,000 something years. So
I was wondering, I kept seeing those when trying to add comets to Stellarium, and I'll send you guys a little link to do that. We talked about it, but there's a little quick link that'll show you how if you want to. I kept seeing the P, and I was wondering what that was about. Yeah,
P for periodic, C for regular comet. The 2020 is the year of discovery. The F, so we take the year and we divide it into 26 2-week blocks, and we assign the letters A to Z. And so the letter F is the second half of March. So F3 means it's the 3rd comet discovered in the second half of March. By anything, not by Neowise, but by anybody. So Neowise is C2020 F3. And because it was discovered by a space telescope, this space telescope, there are lots of comet Neowises. So to get the right one, you need to look for the one that's F3 to find this one. Now, comets drop in from the outer solar system, from the Oort cloud, and this one came in, and what I've got here is a 3D model of the solar system. You can see the sun in the middle and the Earth, the planets orbiting the sun. And then you can see this blue, light blue ellipse. This is the path or trajectory of Neowise. And it came in from below, because they can come in from any direction, came in from below the solar system, which meant that it was in the southern sky, which meant that we in Canada weren't able to see it for the longest time. But folks living in the southern hemisphere got a preview of it, got to see it before us. Then on July 3rd, which I got shown here, it swung closest to the sun, just near the orbit of Mercury. You can see it's just outside Mercury's red circle there. And then each day after that, it's entered the north half, above the plane of the planets. And so it's moved into the northern sky. And for us, it's moving generally in a north and westerly direction. And that's sort of going to bring it under the Big Dipper for the next couple of weeks. As I advance the date here, you can see that the comet is actually sort of heading out radially from the solar system now, and it's actually going to fly over Earth around the 23rd or so of July. So on the 23rd of July, the distance from us to the comet will be at a minimum. And so it will be, in theory, bigger in the sky. But at the same time, it's getting farther from the sun, so it might be fading because it's not giving off as much gas because it's not heated as much as it was when it was closer to the sun. So it's kind of a trade-off. So the quick take on that is that if you want to see the comet, start now, because we could also break up and fizzle out, so you don't want to miss it.
That's the problem with comets, and that's what's happened a lot in the past couple of years or so, is that we get it, all of us, well, some astronomers get their hopes up for some of the comets, and then they break up before they even get close to the sun. Yeah. Just quickly, Chris, Wendy asked, is Chris freezing or is it me? Occasionally Chris is going to freeze, and hopefully it will be at times when he's not saying extremely pertinent information. And if it is, I will ask him to repeat it.
Sorry, yeah, my broadband has already crashed Zoom several times, so we may have a little bit of stuttering here. I apologize.
We are doing our very best.
I'm gonna close this app and open up Stellarium, because Stellarium is better for the showing it in the sky for us.
Was that Starry Night?
That was Starry Night, yeah.
Okay.
So Starry Night actually lets you leave the Earth and view things from other viewpoints in space, which is kind of cool.
That is nice. Gives you a good idea for visualizing it. That's one of the interesting things about, especially with this comet. First of all, it's moving very fast. I mean, I have no idea if other comets move this fast, but it moves fast compared to most of the stuff that we're seeing in space. And so it's passing behind the sun from our perspective relatively quickly, which makes it move from a morning object to an evening object.
That's right.
Which is one of the kind of interesting things when you think about it, when you're like, okay, you can see it at 4 in the morning and then you can see it at 9 at night. And it's like, that's a really weird time jump. But it all has to do with which direction it's moving around the sun.
Well, because it's sort of heading northerly generally, it also means that it starts to escape the horizon of the Earth, and that's when it becomes circumpolar. So for a while it was only morning, and now it's either morning or evening, and then after today or tomorrow it's really any time during the night. Yeah. But during the middle of the night it's just skimming the northern horizon, so it's really not worth seeing when it's so low as that.
And also noting that if anyone's in northern Canada, and further south in the States, you wouldn't be able to see it all night long.
Yeah. Once it gets circumpolar, then it starts disappearing in the bottom of its arc. So yeah, we're lucky now. Canadians have the advantage, unless we live in Yellowknife where it doesn't get dark.
Yes, so there's a band of Canada that has the advantage right now.
Yeah. So last night I went out and I found a location that had a nice open northwestern horizon, and I picked it up in my binoculars at 9:45. So the sky got dark enough to pull it out at 9:45. At 10 o'clock, I could just barely see it with my unaided eyes, and then some clouds covered it up. So that was the limit of our view. But we're going to try again tonight. in Toronto, there's some forecast of cloud off to the northwest, and we're hoping that it stays away so we can still see it. So if you want to know what the comet will be doing, so that there's sort of your timing, depending on, give or take, depending on your latitude, which latitude you're at, sort of 9:45, 10 o'clock. It actually doesn't set until close to midnight, but it starts getting low into the murk. So you want to get it, be waiting when the sky is bright, and then it starts looking at it as soon as the sky darkens enough to see it.
And no matter what, you're going to want to be somewhere where you can see northwest very, very clearly, where there's no buildings in the way, no mountains, no hills. It's like, if you have a northwest facing balcony, you are in the perfect position, but otherwise you want to find a hill that faces northwest so that you can look down onto it.
That's right. A couple of tips that you can do if you have an astronomy app. If you know how to set the time on it, you can set the time for 10 o'clock tonight and pretend, go out in the daytime, set it for 10 o'clock and aim it around the sky, and you can sort of figure out where the comet will be compared to your trees and buildings and things like that. That's a way of doing it. Generally, it's going to be kind of below the Big Dipper. So here's the Big Dipper. And the comet's going to be hanging out sort of on this trajectory. I'll just bring up the times here and show you where it's going to go over the next number of nights.
And remember too that this is the kind of neat thing about comets. We can kind of predict where they're going to be, but you do have to do some hunting for these, especially. So I went out at some unreasonable hour in the morning to go see it, and I had a hard time finding it in a telescope. I found it much easier in binoculars, just because you can search the field of view a little bit. I know I find it easier to search the field of view in binoculars, and you get a wider field of view as well.
Yeah, so what I did is I found it in my binoculars. Luckily there was a tower nearby that I could reference to, and then I had a tracking small telescope that I was able to find the comet in the telescope. So we actually got to watch it magnified through the telescope for that 15 minutes, and it was cool to see the bow shock around the coma where the tail extended, well, up from the coma. So here's where it's going to do over the next week or so. Every night it's going to climb a little bit higher, but by about a thumb's width, and slide a little bit to the left. But bear in mind that as it sets later in the evening, it's dropping down to the right. Most things we're used to looking at in astronomy are dropping down to the left or down to the right because we're kind of looking south. But this one's going to swing kind of the other way. It's a little bit counterintuitive. You think when the sun sets, things go this way, but really when you're circumpolar, you go that way. So that's tomorrow night, next night, next night. So if you can pick up these little stars that are the toes of Ursa Major on the 18th, you can really zoom in on the comet that way. This circle is about the field of view of binoculars. So let's see, when we get around the 23rd or so, that's our sort of closest to Earth approach. It's going to be getting down to the back foot of Ursa Major, and then so on and so on. And if it doesn't fizzle out, we expect to be able to see it through telescopes for weeks and weeks. So this is cool.
That's pretty awesome. It's very exciting. It feels, I don't know, to me it feels very much like an explorer, like it's something new that you're getting to discover along with everybody else. Whereas, you know, a lot of the time, same with on Earth, there are not that many places where you can go where no one else has gone before. And in the sky, a lot of the stuff that's up there has been discovered for a while now. And this is one of those things that it's neat because you kind of get to learn along with everybody else as they're seeing it for the first time.
Yeah. And really naked eye comets are bucket list things. Even seasoned, jaded old astronomers, you know, get excited about them because we haven't seen lots of them. So do make the effort to get out and see it if you have a chance to.
If you even have a passing interest in astronomy, and then you end up developing the interest further in later years, you'll kick yourself if you didn't go out and see it this time.
That's right, because who knows how long it'll be before we get another good one.
Yeah.
All right, so let's talk about our topic. So the kind of objective of what I want to do today is to give people some idea of what to look at in the summertime evening sky, some tips on, you know, how to make it work best for you and that kind of thing. And what we're going to focus on is the real benefit of July, August, and that's the summertime Milky Way. Now, the solar system, our solar system, the planets are all aligned in a plane, but that plane doesn't line up with the structure of the orientation of the galaxy. So that means that as Earth goes around the sun, at different times of the year, we see the Milky Way across the sky, and at other times of the year, it hugs the horizon. We don't really get a chance to look at it. But it turns out that in the summertime, July, August, not only are we able to see the Milky Way sort of rising from the southern horizon, but we can even see the center of the galaxy. Now, because we're now looking at the core or the center of the core of our galaxy, we're sort of getting a concentrated number of cool objects to look at, right? We're getting more nebulas, more star clusters, and things like that. So let me just darken the sky. So this is the sky tonight at about 10 p.m. The reason that we're talking about this week is because the moon is out of the sky and the sky is darker. And if you're lucky enough to be in the country or at the cottage, you're good to go. You want to get on your dock and get your binoculars out and get yourself oriented. You can see that the sky isn't really truly dark at 10 o'clock though. So maybe about 10:30, boom, there comes the Milky Way. All right. So let me kind of orient things. Now this line across here, that's the ecliptic. You can see we've got Jupiter and Saturn hanging out. I'm just going to get rid of the ecliptic just to give ourselves some clarity here. Now, the Milky Way is merely a large quantity of stars that are so far away from us that they all sort of mash together into one glowing band across the sky. The Greek word for milk is galactos. And so the word galaxy comes from galactos, which is spilled milk across the sky because it looked like this white band across the sky.
Wow, I didn't know that. That's super cool.
Yeah. So it's really sort of funny that all those galaxies we see in the universe are all have this linkage back to cows chewing grass and making milk, or goats or whatever it was. So what I'm going to do here is I'm going to bring up a mark on here, and I'm going to, in Stellarium, you can show the galaxy's equator. I'm going to pop that on here and show this. So there's this brown line traces out the plane of our galaxy expressed across the summertime sky at about 10:30 p.m. Now, the other thing you want to pay attention on is when you're looking at deep sky objects, things that are fainter or a little more delicate, they look their best when you can view them through the least amount of the Earth's atmosphere. And so you want to catch them when they're the highest in the sky, because when you look straight up, you're looking through the thinnest amount of air over your head. Now, unfortunately, the Milky Way in the summer kind of hugs the southern horizon, so we don't really get clear of that from southern Canada. But what you want to do is you want to try to time things so that you're catching them when they're due south, because they sort of rise, transit across the meridian, which is the north-south line, and then start sinking again after they pass that. So you can see at 10:30, the Milky Way hasn't quite gotten to the south yet, so it's still rising. But the thing is that if you want to do this during a dark sky, we've got the dark sky, moonless sky this week. The moon's going to come back next week or in a couple of weeks. And then you have a sort of a period where the moon is washing everything out. But like a month from now, you're back in business again. So even if you don't catch everything we talk about today, just make note, come back in August, and you've got it again.
And a month from now as well, it's right around the time of the Perseids meteor shower, which is a nice time to be out observing as well.
Yeah, I've done lots of stargazing or dark sky observing during the Perseids, and I've got my head down writing my notes about something I've just looked at, and the whole picnic table lights up because a Perseid went over.
Oh, that's so cool.
Yeah. So the reason I brought up this this brown line here is I wanted to indicate this 0 mark. That's the exact center of our galaxy. So when we're looking at that spot in the sky, you're looking at the direction of the supermassive black hole in the core of our galaxy. Now, there's nothing to see with naked eyes, and even big telescopes, there's not much to look at there. Of course, astronomers use giant radio telescopes and phased arrays to get pictures of the little stars zipping around the black hole in the middle of our galaxy, but it's cool to know that it's there. And let me just start with some bright stars. So if you head out onto the dock, once the sky is nice and dark, the first thing that's going to catch your eye in the southern sky, aside from Jupiter, is the star Antares. Antares is the kind of the eye or the heart of the scorpion. And you're going to look for the three little stars just a little bit higher and to the right, marking the claws. And then the rest of the scorpion sort of swoops down. And you can see this really cool double star called Shaula. That's a bright star and a dimmer star, and it really resembles the scorpion's stinger. That's the tip of the scorpion's tail.
Oh, yeah, I guess it does, doesn't it? It's got
Now,
that little curve.
If you've been to the Southern Hemisphere, or if you have family connections there, you might know that this hook shape is Maui's fish hook from the movie Moana. So Maui, her friend Maui, was carrying the big hook, and the Maori people see this constellation as Maui's fish hook. And it actually hooks the Milky Way and drags it up out of the horizon for them.
Oh,
so
cool.
That's kind of a neat bit of indigenous astronomy there. So yeah, get yourself oriented with Antares, and then pick up Jupiter off to the left, and you know that the Milky Way is smack dab between them. So that'll be a good guide for that. Now, if you don't have a super dark sky, you can certainly have a lot of fun looking at the shape of Scorpius, the double star I mentioned, and things like that. You want to turn your gaze a bit to the east here and look for the teapot shape of Sagittarius. So Sagittarius has this flat bottom, there's the handle, there's the pointy lid, and there's the teapot spout. And by the time you get later in the evening, it looks like the teapot's tipping and the steam of the Milky Way is rising from the spout of the teapot. It's really a cool effect. So those stars that make the teapot are really pretty obvious, even from, relatively medium dark skies in the suburbs, or as long as the moon's out of the sky and it's nice and dark. So you can pick that up. And again, it's pretty low. It's just over the southern horizon. It'll get higher a bit later in the evening. Now, you follow the sort of Milky Way up and a bit to the left here. You're going to sort of face east now. So now we're facing east, and you can see we've got the bright star Vega, bright star Deneb, bright star Altair. That's the summer triangle. Those are the first three stars that pop out of the sky as the sky's getting dark in the evening in the east. And the cool thing is that the Milky Way runs right through the summer triangle. In fact, Deneb is the tail of Cygnus the Swan. The swan's beak is the star Albireo, the pretty double star. And it's almost like the swan is flying along the Milky Way, getting ready to come in for a landing or take off. And when you've got your dark sky and you've got yourself oriented to Vega, Deneb, and Altair, take a look at the Milky Way and notice these zones of darkness. They're quite obvious to the naked eye, and you can certainly check them out with binoculars. And that's dust that's opaque, and it's blocking the light from the stars beyond. So what you're seeing is the sort of different components of our galaxy. You've got the bright stars collected together, and then you've got the dark dust permeating the disk of the galaxy that darkens those lanes and hides them out. They're pretty obvious. You can see that the Milky Way sort of splits into two zones with a dark patch in the middle. If you keep going, sort of swing around now, look to the northeast, you're going to pick up the constellation of Cassiopeia, the W-shaped constellation of Cassiopeia. And that constellation is also right on the Milky Way. It's not so thick there, not so bright there, because in this case, we're looking at almost the exact opposite direction from the core of the galaxy. So now we're looking at fewer stars. We're looking at maximum stars when we look into the core, and we're looking at sort of minimum stars as we look in the other direction. In fact, the actual opposite sort of part of the galaxy is kind of down here near Perseus and beyond.
And on that note, there was a question in the Q&A in terms of what we're actually looking at. And the question was, what we see of the Milky Way is an arm. Is that right? Do you want to take a stab at that one, Chris?
So first of all, folks should maybe at some point head back and watch our session on galaxies that we did, because we did talk about the shape and structure of galaxy and how it sort of manifests in the sky. But since we're sitting within the plane of the disk of the galaxy, as we look out along the plane, we're going to see the stars nearest to us first, and they're the most obvious ones. So that the arms that wrap around the core, the closest arm to us, say the Orion arm and so on, would be the ones that dominate our sky. And then the more distant, dimmer stars would be the ones more, beyond that. So yeah, when we're looking at the plane of the galaxy or the Milky Way, we're actually looking along the arm, the concentrated stars along the arms of the galaxy. Hopefully
And
that.
I've just linked the our episode on galaxies in the chat. So if you're interested in watching that, that would be a good one to watch.
Yeah. So in terms of kind of naked eye astronomy or binocular astronomy from the city, you want to check out Antares, you want to look for the teapot. If you head on up above the two of them, you can find this big guy called Ophiuchus. He's called the serpent bearer. I'll just draw the art for him because he's actually holding a broken constellation called the snake, the serpent. Here's the tail half and here's the head half. And you can pick up this triangle of stars that form the snake's head, so you can sort of get a sense of where you are. Look for the northern crown above it, and then you'll know you're in the right ballpark. Now, to me, Ophiuchus actually looks like a Dalek from Doctor Who. He's sort of got that pointy lid and that right shape. And these stars here that are quite obvious in the real sky, those are the disintegrator stars coming out from there. You can see that the stars in Ophiuchus aren't quite as prominent as the ones in Antares and Scorpius, but
if you'll
you can definitely see them.
If you'll entertain me for a second, the zodiac signs, they go around, the different constellations go around the sky along the along the ecliptic, and the zodiac signs are where the sun is when you were born. That's what your zodiac sign is. So if the sun was in Libra, then you are a Libra. It just so happens that in fact the sun goes through a 13th constellation that isn't in the typical zodiac that you see, which is Ophiuchus. And now that you're saying that it looks like a Dalek, that's a very good point. So anyone who is an Ophiuchian, you are, in colloquial terms, a Dalek, as it is now.
And you know what, Jenna? That's me.
Are you?
I'm a Dalek.
Oh, you lucky man.
I am. So let's just carry on a little bit on the bright stars. So we've got the summer triangle. You've got a pretty good handle on them. Try to see if you can find the star Albireo, which is sort of in the center. We talked about this last session in our one of our sessions where we talked about Albireo being a flux capacitor, the core of the flux capacitor shape of the three stars in the triangle. And Albireo in a telescope splits into a beautiful colored double star. And I won't tell you what the colors are, but I'll let you discover that for yourself, because Stellarium doesn't do them justice.
No. It's an easy one to find too, and you can see it even if you're in the city, so it's worth a shot.
And the famous double-double is up here near Vega as well. All right, and then we're going to focus on the summertime Milky Way. So we're not going to worry about the Cassiopeia back half, because that's actually up in the sky during the wintertime. Let's focus on what's cool about the summertime Milky Way. So I'm going to take off the galactic plane here and just sort of make the sky a little bit plainer.
While you're doing that, I'll just quickly mention, I just typed it out, but there's a question about how to find Andromeda with Cassiopeia. And we'll probably talk about that. Well, we will talk about it more in October sort of times, because you can't really see it too well now, but you can. If you're looking for the W of Cassiopeia, the larger side of the W points directly at Andromeda. So keep an eye out. Yeah, there it is.
There's Andromeda right there.
So you can see the fuzzy spot. Yeah.
So yeah, there's Andromeda right there.
And
it's actually up now. It's sort of a midnight and after target right now. But yeah, that's a topic for a future date.
Yeah, we'll talk about that.
Our own galaxy right now. So remember that what you're doing when you're looking at the summertime Milky Way is you're exploring your own backyard, your own home galaxy, right? And when you're looking to the south, I mentioned that we could see the core of the galaxy, we could see the dark dust lanes. Now look around and you can see, just with unaided eyes or with binoculars, you're gonna explore and discover little knots of stars, little clumps of stars. Those are star clusters, open clusters. You're gonna see maybe some, if you're lucky, some brighter pinkish patches. Now with the naked eye, you're not gonna really see the pink, but if you do a tripod mounted camera long exposure, you can definitely pick all of this detail up without a lot of effort. If you have a nice dark sky. But what we're doing is that people like Charles Messier and the Herschels, who were mapping the sky and sort of collecting all these deep sky objects, they were exploring the skies in a search pattern, and they were noting all of these cool clusters and nebulas and objects that they discovered. So if you start with your binoculars and just head south, you're gonna stumble upon these little knots of gas, glowing gas, and many of them have stars in them. And what I'll do is I'm gonna bring up and identify them for us. And there's just loads and loads, so I'm just gonna dial back some of the labels here.
It's a busy place, the center of the galaxy.
Oh yeah. So let's do this. So if you're using Stellarium or an app, some of the deep sky objects will be coded with a particular type of shape of symbol. So the dotted circles, you can see there's a big one here and a small one here. Those are the open clusters. So those are just loose knots of stars that are generally all siblings of one another. They've been born together. They're traveling through the universe together. Sometimes they eject a member and kick somebody out of the family, but generally you see them as knots. And I'll zoom in on a couple of these in a minute. And this, I've got Stellarium set up so that the biggest and best objects have a bigger symbol. So you can see that here's a small open cluster, here's a giant one, and here's one in between. So this sort of gives you a relative sense of how bright or how easy they are to see.
You're the master of Stellarium.
Oh, it's an easy trick. You go into Deep Sky tab and you say, use proportional hints.
Ah, cool.
Then it's dead easy. Otherwise, they're all the same size.
Huh, neat.
Yeah. So it's kind of a neat way for someone to figure out what are my best odds, what can I most easily see.
Mm-hmm.
So let's zoom in on a couple of them. The easiest, biggest one here is this small Sagittarius star cloud. And in binoculars, and I'm just going to turn off the symbols here. You're kind of looking at an absence of the dark dust that opens a window into the myriad of stars beyond it. So rather than it being necessarily a patch of stars assembled, it's more like somebody cleaned the window and you're seeing through it a little bit better.
That's so cool.
Yeah. So that's the small Sagittarius star cloud. You move down a little bit to where's that other one we saw? Let me just bring up the symbols again here. This is called Ptolemy's cluster, or it's number 7 in Charles Messier's list of objects, Messier 7. And again, as you magnify it, you're going to see. Now, what's fun to do with open clusters is to kind of make a shape out of them. Maybe it looks like a tarantula, or maybe it looks like your initial or something. Like this one almost looks like a K or an R or something like that with the bright stars. Now, the other thing you can do in Stellarium, if you have an internet connection, is you can flip on this DSS image, and that'll put the all sky image on here. Let me just turn off the stars. So that would be like a photograph of the sky, and it's not quite as maybe as obvious as the Stellarium makes it look, but that's kind of how it would look. I think it actually looks better than that in real life. All right, let me just bring this back on.
This is why you have to go out and observe, so you can
see
what it looks like for yourself.
Let me just turn that off. Here we go, and turn on the stars again. Here we go. So that's Messier 7, Ptolemy's cluster. And what you can do there is you can kind of start with the stinger of the scorpion and just sort of run your binoculars a bit to the upper left, look for that knot of stars. Then you can go a little bit higher. You can find a couple here and keep going up. And at some point, you're going to run into this bright knot. And you can see that's not an open cluster. It's got an outline. That means it's a nebula, and the nebula often has stars inside it. I'll come back to that in a sec. And then you've got the big star cloud. And if you keep going, you're going to catch a really neat one up here. And this is called the Wild Duck Cluster. And if you have a telescope, especially if you have a go-to telescope where you can dial in Messier 11, M11, the Wild Duck Cluster is a really big, bright, open cluster. It's really a cool one to look at.
Ooh. Does it look, why do you have any idea why it's called the Wild Duck Cluster?
No.
Who knows?
I don't think it does, but maybe somebody,
Does
you
anyone work
know,
for Ducks Unlimited or part of Ducks
yeah, who
Unlimited?
knows? Well, it was named a while ago, right?
Probably before
Right.
Ducks Unlimited.
So object number 2 here are the circles with a cross in them. And these are globular clusters. So we talked about globular clusters in one of our previous sessions. These are spherical balls or orbs composed of thousands, even up to 1 million stars, all gravitationally bound into a spherical shape. And in the core of those clusters, the stars are so close together, they're only like light weeks or light months apart rather than light years apart. They're so intensely packed together. And there's a really neat one, easy to find one, right near Antares. Remember that bright star Antares in the Scorpion? So if you put your binoculars on, let me just bring the binocular view up here. There we go. So put your binoculars at Antares and look just to the right. You're going to pick it up. That's just called, I'll bring that back. I can't name them when they're not enabled.
That one's M4,
That's Messier
right?
number 4.
So I found this one, but it took me so long because I thought I had written down the right direction, but my brain had read it as the wrong direction, and I wasn't looking in the right spot.
Yeah, no, that's a good point, Jenna. So remember, if you're using a telescope, that it will flip the view around.
Mm-hmm.
So even though you could point your telescope at Antares and then sweep it over to find M4, you'll need to go perhaps the opposite direction of what you think, because the telescope optics, the mirrors and lenses in the telescope can flip the view around for you.
Practice in the daytime, everybody. Don't be me.
Yeah, or use the moon. Just see what does the telescope do to the moon, and that's always going to be the same effect. So that's M4. And if you've got a really dark sky and you want to take a photo of this patch of the sky along exposure, you're going to pick up some of this really cool, intense colored nebulosity. This is the gas in the galaxy's plane being illuminated by the bright stars within it. So you've got Antares lighting some of the gas up, and you've got these blue glows that are dust being scattering starlight off the dust around surrounding these stars.
Mm.
So that's a really neat patch of the sky to image or to study. All right, so let's go back to the globular clusters again. If you go up to our friend Ophiuchus, the Dalek, he's got a really neat little open cluster above his disintegrator or his pipe, depending on your interpretation. And in the middle of them, he's got some really cool globular clusters. And again, you can find these in your binoculars. They'll look like a faintish, fuzzy patch, like a star that's got fuzz around or halo around it. And most good binoculars will pick them up, and you can just sort of sweep around and look for these. If you have an app, you can sort of track down which ones they were when you saw them. This is Messier number 10 in the list. This is Messier number 12.
Oh,
this is
Gumball
14.
Globular Cluster. What a fun name.
Yeah. Some of these names are, maybe they're not International Astronomical Union and endorsed names, but they're fun.
They're
whimsical.
fun. And they're memorable. That's what matters, right?
And again, don't forget that I'm just showing you the best, the brightest ones. I mean, if I crank up these sliders, there's all kinds of the objects buried in the galaxy here. And there's another one down here, Messier 107, and so on. So do take a look. Now up in the teapot, you've got a globular cluster, Messier 54 down near the bottom east corner of the teapot. You've got M Messier 69 near the other corner of the teapot. You've got a star cluster below the spout, and you've got Messier 28, Messier 22, and then a non-Messier object as well. So you've got all kinds of these little things that you can pick up as you go along.
And just so you know, this is a bit of a backtrack, but we've had a couple of folks, Joe and Katrina on YouTube, Joe on Zoom, mentioning that the wild duck cluster got its name because there are 3 stars that make it look like like flying ducks in a V. And from some perspectives, it looks like a swimming duck as well.
All right,
Wrapping up
let's
that
see if
timeline.
that's
Thank you
true.
for that.
I'm gonna
Let's
see if that's true. I'm going to put on the deep sky objects here. Let's see if we can see that effect.
This is why this is these asterisms that people see, and you kind of go, oh, it kind of looks like that. Sure, maybe. I don't know.
I'm not seeing here, but maybe in real life it would look that way. I don't know.
If anyone goes and observes it, report back in 2 weeks and let us know what you thought.
Absolutely. Absolutely. All right. Okay.
And there's a question as well about globular clusters.
Yep.
Are they all on the plane of the Milky Way?
They're actually their actual position in space. So the open clusters that we pointed out are all within the arms of the galaxy because they're the areas where the stars are concentrated. The globular clusters are actually in orbit around our galactic core, but they're external. So whereas the Sagittarius star cloud is, well, that's not a good example. How about the Ptolemy one? This one's about 978 light years away. The globular cluster, Messier 4 here, is 7,000 light years away.
Wow.
Kind of outside the plane of the galaxy. They can really be in any, well, they tend to be towards the galactic core from our perspective because they're sort of orbiting around the galaxy's center of mass. But they can actually depart from the plane of the galaxy quite a lot. So whereas a lot of the open clusters tend to be along the galactic plane, the globular clusters can be found scattered about quite dramatically. All right. All right, let's talk about the nebulas because these are cool. So I'm just gonna. So if you take a binocular, go ahead.
I'm really excited because I know we're looking in the south right now, but I saw the Ring Nebula for the first time last night.
Now the Ring Nebula being a stellar corpse, it can be wherever there are stars, which means that planetary nebulas can be in any direction from us, from our perspective. Well, we'll take a look at it in a minute if we have towards the end.
We'll see if we have time.
So as you sweep with your binoculars from Shaula, kind of up along the Milky Way, you're gonna encounter a bright sort of cloud or fuzzy patch in the sky, just above the teapot's spout and a pointy lid here. And that one is the Lagoon Nebula. And if you have a telescope and you can magnify in on the Lagoon Nebula, you're going to see a combination of a young open cluster being sort of formed out of the hydrogen gas that's enveloping it. And the hydrogen gas is glowing by the radiation of these young stars and producing a pinkish or a red light because of the emission of hydrogen, the element hydrogen. And so what you're seeing is both the kind of the baby and the crib at the same time. Mm-hmm. And in a long exposure photograph, you can start picking up some color and that kind of thing. In your telescope, if you have even a modest telescope or even a larger one, it's going to appear mainly in black and white, but it's still really spectacular. And a neat tip for looking at these nebulas is to get yourself an ultra high, a nebula filter or an oxygen 3 filter. It screws onto your eyepiece. And what it does is it darkens all the sky around it and leaves the glow of the hydrogen gas to illuminate, and it brightens up the nebula and it dims the stars. Interesting. And there's obviously one of these little globulars. This almost looks like an open cluster, but it's sort of nearby. So just, as you sweep around, you're going to discover all kinds of cool things. So this is the Lagoon Nebula. Head back out a minute here. And again, this comes up in binoculars from a dark sky easily. You can easily pick that up as a bright patch. Then you've got the star cloud we talked about. And then if you come up a little bit higher, there's one here called the Omega Nebula or the Swan Nebula, Messier 17. And what's cool about this one, I'm just going to turn off the symbol here, is that it has a bright concentration of gas that literally looks like a swan floating on the water. So here's the swan's tummy, and here's his curved neck, and head up here. So he's upside down from our point of view. I can flip it over. There you can sort of see the swan swimming down, and it's quite evident in a telescope, even a medium or small size telescope. And if you have a nebula filter, it really helps a lot as well. Because he's sort of tipped head down, then your telescope is maybe going to flip him upright. So depending on your optics. Depending on how good your sky is and how big your telescope is, you're going to pick up some more of the sort of knots of nebulosity around him as well. But that's the Omega Nebula, really, really cool object. You can see that they have all these other nicknames that people have come up with that they interpret the shape differently. But to me, I always see a bird floating on the water. That's what I always see when I look at it.
Well, now that you said it, we will all see it too, Chris.
Yes, it's like Wilma Flintstone.
It's like the Wilma Flintstone effect, or the mouse, as John gave us 2 weeks ago.
The mouse of Leo. If you go straight up from there, and if you have a telescope, you can actually sweep your telescope in the appropriate direction and just hop from one object to the other. It's pretty easy to do that. They're going to pick up the Eagle Nebula, Messier 16. And again, it's a mixture of these young stars that are being born in their nursery along with the gas around them. So you're seeing the star forming regions of our galaxy. Just see how our time's doing here.
It's 4:15.
That's that one. And there's another one over here. What do we have over here is I don't have all of these. Let's see if I crank up my sliders. We'll get some more names.
This is the part, so this is kind of fun thing. I really like the southern sky because you can poke around it and find all sorts of cool stuff, but it's much easier to get lost because there's so much down there that you're kind of bouncing around from one fuzzy object to the next.
Yeah, so what you want, that's why I started off the session by kind of giving you the teapot, giving you the Antares, because you can use those as your markers, your guideposts. Actually, this constellation of Scutum, the shield, when you see it in the sky, it really, to me, more resembles a narrow kite shape. I don't sort of include the star down here. And it kind of is that pointer that points right down towards the star cloud. And the wild duck cluster is sort of tucked up near the top edge of it. So you can pick that up. And a good way of getting there is to actually use Altair, which is the part of the summer triangle. So this is actually the head of the eagle. The wings extend sort of north and south from that way. And if you run down the eagle's body and then down to the tail, then the next little patch you're getting to is the Scutum area where the wild duck cluster is.
There you go.
Now, carrying on up a little bit further, as I said before, we get into the Cygnus, the area where we have Cygnus the swan. And this is another one where binoculars are great if you have a dark sky, because if you point your optics at Deneb and then sweep just a little bit sort of below or to the east of Deneb, you can pick up this nebula here. And this is actually the North America Nebula. Can you see that there's Mexico, there's the Gulf of Mexico, here's where Florida would be, Canada would be up here.
Oh yeah.
So it's sort of on its side, but that's North America Nebula. And then down here, this other patch of nebulosity, that's the Pelican. And they're the same cloud of gas. It's just that there's some dark dust that's been intervening that kind of divides them into two lobes. But they're really this one and the same part of the galaxy.
The dark dust, would that be in front of the nebula, or would it be
in the foreground? Yeah, between us and the nebula. Yeah. And again, don't forget, that's the field of view of binoculars. So just give you an idea that if you put your binoculars with Deneb near the kind of the top, now Deneb is really bright. So you probably want to hide Deneb just off the view above, and that'll reveal a little bit the dimmer nebulosity. And again, you won't see the pink necessarily because it's, not enough photons to the binoculars, but a lot of our friends that are imagers, in no time at all, they can pick up the pink color in the North American Nebula.
A lot of visual astronomy is just looking for smudges, unless you have really big telescopes, in which case Chris has it's a foot wide one?
Yeah, 12-inch.
A 12-inch, yeah, and that brings out a lot of detail, but otherwise it's a lot of just it's a lot of looking for different shaped smudges and maybe sometimes different colored smudges.
Now, let me just pull back here. Again, you can see some little knots and things that are enhanced in stellarium, but they're really much tougher to see in a telescope or binoculars. But the North American Nebula, I can tell you from firsthand, is a pretty easy to catch if you have a dark sky. Again, there's our friend Alberio. Remember I talked about the nose of the swan and the double star. And if you look, let's see if I can pick out, I think it might be this star. One of these stars in the neck of the swan is the big blue giant, supergiant star that Tom Bolton observed and confirmed the first black hole, Cygnus X1 black hole. So Cygnus X1 because it's in Cygnus, and it's X1 because it was the first X-ray source. And Tom Bolton, using the David Dunlap Observatory telescope, did spectral analysis on the big blue supergiant star that was in the area of this X-ray source, and determined that the spectra was telling him that it was being blue shifted and red shifted because the star was being yanked towards Earth and away from Earth on a quick time scale that was due to a massive object pulling it around. It's kind of like if a dad and a daughter are dancing in a circle, that's the dad is moving less, the daughter's moving more. Mm-hmm. So if you can think of the black hole as the dad and the blue star, the giant star, was the daughter, mm-hmm. It was being sort of pulled around. And so he published his results, and he got credit for discovering or confirming the first black hole in history. In Canada, at the David Dunlap Observatory.
Yes, shout out to Toronto's giant telescope. It's what, 72 inches? 72?
74 inches.
74.
72 is the one in Victoria. So we have a 2-inch
jump on them.
2-inch jump. Yeah.
I recommend that spinning a small relative of yours around in a circle experiment, but make sure that you do it safely. Because I often recommend that to young children who are like, ooh, where's the closest person I can hurl in a circle? So just be careful if you're going to do that experiment, but it's a fun one.
Yeah. Now, while you're in the neighborhood, I talked about Alberio. The other thing you want to pick up is if you find, so here's our friend Vega, which is the brightest star in the summertime sky. It's close to the zenith. It's almost overhead around 11 p.m. right now. So just look very high up in the east and you're going to find Vega, no problem at all. And then if you come down from Vega towards Altair, but stop halfway with your binoculars, you're going to pick up this thing. And this is the coat hanger. Can you see there's star, 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 star in a line, and then a hook of stars below it. Kind of an old-fashioned coat hanger. And again, it fills a good percentage of your binoculars. This is probably pretty wide for a pair of binoculars. I think most binoculars would show a smaller viewport than that. But that's a cool thing to look for.
And that one's better in binoculars than it is in a telescope, because in a telescope, it's too big.
Yeah, a telescope won't fit it all in, so you're not really picking up the shape as readily as you do for that. All right, let's see what else we have here. I'm going to stick with the easy stuff, and then we can get into some sort of more challenging stuff if people want to a deeper dive. Oh, almost forgot. So Cygnus, you want to look for Deneb, the tail, the star Saturn, which is the chest or the heart of the swan, and then Alberio is the head. And then there are wings extending above and below. And if you go down one joint of the wing, so first joint, second joint of the wing, look for a star that's offset a little bit to the right. That star's name is 52 Cygni. I think it's Genia in some apps. And if you point your telescope and your binoculars right at that fainter star and zoom in, you get this. Oh.
That's beautiful.
And that's the Veil Nebula. And the Veil Nebula, we believe, is the remnant of a star that exploded in a supernova. And it's blasted into a rough circle. So these are shock fronts that are expanding slowly over time. I've forgotten at the moment when the supernova was thought to have happened, but it would be, thousands of years ago now. I've even read theories that maybe there was more than one star that went supernova to contribute to this. But you can see it's a very complicated shape. So it's started off more compact, and now it's sort of dissipating, and you're getting segments of it. So if you point your telescope at that star 52 Cygni, it's very easy to see in binoculars. It's a naked eye star, and it's real easy to point your telescope at. As soon as you do that, if you look carefully, you can see this band of brightness that's running right diagonally through the star. And if you have one of those oxygen filters or a nebula filter, you can darken the sky and you can really see this really neat edge of the supernova remnant. And then if you pick up the curve to it, you can see it's sort of it's convex on the bottom here, this curve shape, and move your telescope in that direction and go for a little bit, then you'll find the other half. So one half is called the eastern veil and one half is called the western veil. But if you get into an image of it, you can pick up all of this other detail that's all around it. Now, bear in mind, it's really big. See the binoculars?
Yeah.
So it measures, let's see, in the sky, it would measure from here to here, about three finger widths across in the sky.
That's pretty darn big. That's
But it's
6
definitely
times
worth
the size
looking
of the
at.
moon.
That would be 6 moons across.
It's a lot.
Yeah, 6 times the moon across. So that's a supernova remnant you can check out. All right, let's go on up and look at Vega. So Vega's, as I said, super easy to find. If you hold up a finger and tuck your finger against Vega, then the star that's on the other side of your finger is this one. That's the double Epsilon. And if you put your binoculars on it, it'll break up into 2 little stars. And if you point a backyard telescope on it, as we discussed during our session with Blake a while back, let me just change my settings so I can make the star smudges not so big.
We have an entire session dedicated to double stars. If you guys are curious, it's on our YouTube channel.
Yeah. So see what I just did is I took those smudges, and each star is 2. And we think that one of these stars is orbiting the other one, and one of these is orbiting the other one. And not only that, we think that these 2 are orbiting these 2.
Wow.
Kind of a super cosmic square dance.
That's very cool. Have we seen them move at all around each other, or do we just theorize?
I believe over time we have noted a small amount of change. I think that as we observe these stars over a longer period, when we collect more data on their trajectories, then we can better resolve their orbital paths. Blake, I think, mentioned some of that when he was talking about it.
It's very cool.
So that's the double. Let me just bring my parameter back up here, so I'll make the other stars look normal. So that's tucked in right next to Vega. Now, there are people that can see that it's a double star with their unaided eyes. So check out, see if you can. But definitely your binoculars will pull it apart, and your telescope will also pull it apart. And as I know Jenna discovered at an observing session not long ago, all the 4 corners of the Lyra are doubles.
Some of them are, it's so cool.
Yeah, some of them are wide apart, and some of them are close together. These ones are tucked close together, and these ones are more separate. This star here in the middle, so it's sort of a triangle with reference to the bottom of the other 2. This is another Albireo. It's just like Albireo. One star's brighter, one star's dimmer, and they're 2 different colors.
Oh man.
So that's one to check out.
I haven't looked at that one yet. I'll have to give that a look.
And I don't know if you can see, there's a tiny little bubble right there. And that's the Ring Nebula. And the Ring Nebula is really easy to find because all you do is you take your telescope and use your finder scope and aim it exactly halfway between these 2. And it's just a little bit above the view. So if you start with your long focal length eyepiece, the one with the biggest number on it, that gives you the biggest field of view in your telescope. Then even just eyeballing the middle of this span will give you the Ring Nebula usually in your telescope. And so then once you've got it, you can zoom in.
When I found it last night, I didn't even have to, like, normally I would go to the brightest star and then scan down, but I just kind of spotted it with my finder scope and I didn't even have to adjust. It was right there. It was so cool.
Yeah. So it looks like well, you tell us what you saw.
I saw just barely a fuzzy circle that I actually had to use averted vision to see. But yes, it was a fuzzy circle. Some people, I don't know, it looks a bit like an eye to me, and it does have that kind of almond shape, which is kind of neat. It's not just a circle. It's got a little bit of an oblong shape.
Yeah.
I did not see
So-
color, but I was told that if you can take a short photo of it, you do see color.
Yeah, the color is pretty intense. It comes up not too badly. Yeah, so if we were naming these today, so for example, the teapot is the upper half of the constellation of Sagittarius, because there's more of the constellation that looks like something else, looks like an archer, I guess, to someone that named it. But I think if we were starting from scratch and naming things now, we would have just called that the teapot constellation. And if we were naming this object, we'd probably just call this the smoke ring.
Yeah.
Because in a telescope, it just looks like somebody blew a smoke ring. And if you've got a night of good seeing, good air, you can look for the little tiny white dwarf star in the center. So the way these objects work is that when a star of similar mass to our sun exhausts the supply of hydrogen in the core that's fusing into helium, the furnace in the interior of the star then shuts down because there's not enough fuel. And that causes the gravity of the mass of the star to collapse on itself. And when that increased pressure gets to a certain threshold, the heat inside the star is sufficient to start igniting again. And now the helium starts fusing into heavier elements. And eventually that process goes on. And at some point, they get to the point where they can no longer burn inside the star. So the star collapses, and then it basically rebounds and it throws off its outer layer, its skin, or its outer, sort of the white part of the apple, if you want. And what's left behind is the old core of the star, and that's the white dwarf. So a white dwarf star is actually a reincarnated star, like our sun. It's just the core of the star, and it's not fusing anything. It's just a hot ember that's cooling down over thousands of years. And the radiation from that sort of naked core is energizing the gas in the former envelope of the star and giving you the different colors. And depending on the composition of the star, you get different colors. So I've seen other photographs of the Ring Nebula that have greens and yellows and other colors that are sulfur and oxygen and other elements that were in the star.
Also, Heather Doucette pointed out that children and or myself included would call that the space donut, which is, I think, an excellent name.
Space donut. Let's see if we can find, the dumbbell. So tucked in between, let's start this again, tucked in between Deneb, which is the tail of the swan, and Altair, which is the head of the eagle. And again, don't forget, there's our coat hanger cluster right here. So we're kind of in the middle of the triangle. You can look for a little set of stars called the arrow or sagitta. So it's got star, 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 and then it splits into the tail of the arrow. And just a little bit above the tip of the arrowhead is the Dumbbell Nebula. And it's another one of those planetary nebulas like the Ring Nebula, except this one's actually quite a bit larger than the Ring Nebula. So it's bigger, but it's a bit fainter. But if you've got an 8 or a 10-inch reflector telescope, for example, you can pick this one up. And again, if you have an oxygen 3 filter or a nebula filter, you can really enhance the view of it. To me, it rather than a dumbbell, I always think it looks like an apple core. But
oh yeah, it's like the chewed out middle part.
Let me just see if I can get the all sky survey image of it to see what that looks like.
I got to see the Dumbbell Nebula for the first time because of you, Chris.
Yes, that's why it's good to go to star parties.
It sure is.
So this is a bit overexposed. So you're actually seeing the entire sphere of the gas, whereas normally the dumbbell shape is sort of an enhanced portion of it. You can see faintly the rest of the sphere of gas. So it's the same process. The star collapsed and exploded. It's just that maybe the star was spinning in a different way or something, and it produced a different effect. So that's the dumbbell. And the one other thing I want to show you up in Cygnus, up in Cygnus here, is if you go to the upper wing of Cygnus, so find the elbow and head on out to the sort of wingtip. Before you get there, You want to put your binoculars kind of on this star and look down a little bit. You'll need a telescope to do this, but there's a little object, another planetary nebula, and this one's called the Blinking Planetary. And what's cool about this one is it does, it's a really great demonstration of the principle of averted vision. So if you stare at directly in the eyepiece at the nebula, you're going to see mainly the bright white dwarf in the middle. But if you then pay attention to the star off to the right here, the envelope, the round sphere, pops up in brightness because it's now your averted vision is picking it up. And if you flip your attention back and forth, you can make the envelope blink. So bright, dim, bright, dim, bright, dim. That's why it's called the Blinking Planetary Nebula.
Cool. Can you see the little like interior bubble at all?
You would need a big telescope or a long exposure.
Oh.
I've actually seen this object through the 74-inch at the DDO.
Ooh.
And not only can you see the color, but you can see the inner bubble and it looks almost like an embryo. It's sort of a cellular nucleus.
Like a mitochondria.
Yeah, like a nucleus of a cell.
That's so cool.
So yeah, hopefully we can get back to the DDO, we can get it open and we can start showing folks.
Can you tell that we're all itching to do stuff when we can't? We all want to go outside and show everyone the sky and tour around big telescopes and observatories, and we will soon. We're getting there.
All right, so I've given you quite a bit of good things to look at. Let me think. I've got about 20 minutes left. So any questions, anything, requests?
So far, I have just been bugging you the entire time that we've been talking. So no questions right now.
Let's see. Yeah, I mean, it's really amazing what you discover. Go ahead.
It's the opposition of Jupiter tonight.
Oh yeah, let's talk about that.
Yeah.
So it's not only the opposition to Jupiter, but there's more to it than that. So the Earth and all the other planets are orbiting the sun in the plane. I showed you the 3D model earlier. And the planets that are closer to the sun, they orbit faster than the ones that are farther out. So Jupiter's takes about 12 years to orbit the sun. The Earth takes 1. And that means that Earth passes Jupiter on the inside track 12 times for every orbit, every full orbit of Jupiter. And so once a year, Earth passes Jupiter on the inside track. And when that happens, then the Earth is closest to Jupiter for the year. Because a lot of the time the Earth would be on the other side of the sun from Jupiter, and so it'll be farther away. And so tonight is the night for 2020 that Earth is closest to Jupiter. Now in theory, let me just put this on here. That means that Jupiter will be the biggest in a telescope, brightest in the sky. It also means that it's opposite the sun, because if we're between the sun and Jupiter, it means that as Jupiter comes up, the sun is going down and vice versa. So at opposition, this is called opposition, Jupiter is visible all night long from sunset to sunrise. And it's the closest. You can see here the magnitude is minus 2.75 and the distance from Jupiter is 4.13 astronomical units, or 4 times the distance between the sun and the Earth. But don't get worried if it's cloudy tonight, because it really makes little difference if you see Jupiter tonight or even a week from now. It'll still be nearly as big and bright. It's kind of a, a slow motion effect. It just happens that it's just a little better tonight than it would be tomorrow or the night after.
The reason I find it so exciting is because it means I don't have to wait up until 11 p.m. to see Jupiter anymore.
Yeah.
It rises after sunset.
Yeah. Here's the other cool thing. There's Pluto.
Hey, Pluto, buddy.
Pluto was at opposition tomorrow night. And because the oppositions sort of happen, sequentially as you move east along the ecliptic. Let me put the ecliptic back on here. There's the ecliptic. So you can see that Pluto and Jupiter are not quite exactly on the plane of the solar system. So yeah, tonight is Jupiter, tomorrow is Pluto. Now that means that Pluto, which is really hard to see, is at its brightest and closest for the year as well. But Pluto being at magnitude 14.25, it's way beyond amateur telescopes generally. But you could take a photo. You could actually take a photo of this patch of the sky. So if you picked up the star 53 Sagittarii or this other one here, and Pluto would be located about a finger's width to the upper left or northeast of them. And if you could sort of get your camera or your telescope pointed in that bit of the sky, you could make a sketch. You could say, well, what are the brighter stars I see here? And then come back in a night or two and do it again and see Pluto will move. So if I put my, I'll center stellarium on this little star and I'll advance. You can see that's not not Pluto.
I thought that was Pluto.
Yeah, no, Pluto's too dim. All right, there's Pluto. Pluto's that one.
So maybe finding that brighter star would be a good way to go because it's right
this
beside
star
it.
Is
right beside it.
Let me just pick this one up. Yeah, let's go off.
The catchy name HIP 96913.
I'll go back a night here so I can do that. Yeah. So this star is magnitude 11, which is certainly fine in telescopes, but not, it's kind of getting at the limit for binoculars. But if you could find that in your telescope, then you could watch night after night after night. You could see Pluto passing by. Now, normally planets are supposed to be heading this way, but because we're passing Pluto and Jupiter on the inside track, it puts them in retrograde. So compared to the background stars, both Jupiter and Pluto are heading west instead of east.
Any of you astrology people out there, that is what retrograde motion means.
Yeah. So if I advance the date, you can see how both Pluto and Jupiter are heading off to the right of the picture.
And Saturn comes in too.
Now there's Saturn. So guess what? Saturn reaches opposition next week.
Woohoo!
Let's see. When is it?
It's on the 20th. I have it written down.
Yeah. Tuesday for Jupiter, Wednesday for Pluto, and Monday for Saturn.
So it's a good time of year and it's exciting as all these things are coming up that we no longer have to wait until the wee hours of the morning to look at them.
Now, the other benefit of viewing planets when they're at opposition and they're closer is even though the planets themselves may not be dramatically better, their little moons are at their peak as well. So you have your best odds of seeing more of Saturn's moons or even Jupiter's moon Amalthea, which is sort of its next down from the Galilean moons, at around opposition. So for the next couple weeks, take your scope out, take a look at Saturn and Jupiter.
Could you see Titan, Saturn's moon Titan in a telescope? Yeah, you should be.
Dead easy. It's dead easy. Even a tiny wee little telescope. So here's the view. Let's see. Here's tonight. So here's the view tonight at about 11 p.m. So you see how the rings are tilted a little bit, lower left, upper right. So just look up. Now your telescope might flip it around, but Titan will be the most prominent dot near Saturn.
Okay.
And because Saturn's axis of rotation is tipped towards the sun, or tilted roughly towards the sun right now, but it's tilted comparably to Earth's axis of rotation. That means that the rings open up so we can see them. It also means that the moons can be above the planet or below the planet or to either side. And of course, just like Jupiter, they vary night after night. So you'll see different rain. So Titan will be above Saturn tonight, but a week from now, it does about a 50%, it does about half an orbit around.
That's cool.
Yeah. So in my skylights every week, I note where Titan is and I mention where it will be in a week. So it does a counterclockwise.
Cool. I'm gonna have to pay more attention to Titan.
How are we at?
We still have a few minutes. We can always wrap up soon. There is one question though, which is what are your favorite things? Not just what's spectacular, but what are your favorite things to observe in the summer sky?
If I have a dark sky location without the moon, I always look at the Veil Nebula. And what's great is that it's easy. By using that star near the wing as a reference. It's so easy to find. I love Albireo. I love showing people Albireo. Binoculars, just take a tour. I love doing that. Let's see, what else?
A shout out from Emma, who's in New Brunswick. M13 is gorgeous as well.
M13, yeah. Now, I didn't cover M13 because it's a little bit off the beaten path for the Milky Way, right? But M13 is sitting up here. So let's just bring up the. So M13 is what would be a summer show piece. And what's cool about M13 is that if you find, remember I talked about the triangle forming the snake's head and the ring of stars forming the northern crown. When you've picked up the northern crown, and also you've got the bright star and Arcturus sitting here as well, just look to the left and look for the keystone box of Hercules's body. And then a third of the way from the wide end on the western side, just point your binoculars and you'll pick up Messier 13. That's the big globular cluster. It's pretty well the best and brightest globular cluster in the northern sky for us. So this is the one you want to look at in the summertime.
It's a good one. There's another question as well. Any other asterisms that you like? I know you mentioned the ET cluster last time, so we've already heard that one, which is lovely. If you want to show it again, you can. And Larry was just saying that the coat hanger is one of their favorites.
Let's see. Well, of course, the dippers are asterisms.
Yeah.
Let's see what else.
Even I would say, technically speaking, the keystone of Hercules, his body is an asterism, I would say.
So these are the, let me just turn these off for a second.
Oh, mini Cassiopeia, that's cute.
Yeah, so these are the asterisms that Stellarium shows if you switch those on. So you can turn Hercules into a butterfly.
Aw.
You can, of course, Boötes looks like a kite. You've got the square of, you've got the teapot, you've got the fish hook. And then you've got the square of Pegasus that's just coming up in late evening now. And let's see what else we have here. Yeah, Mini Dipper, Arc of the King, and so on.
There's some neat ones. That's a good one to explore if you're looking for stuff to see in Stellarium. And the nice part about asterisms is you can just make up your own.
Exactly. I think there's one. Let's see. There's one up here. I can't think of it right now, but
I'm gonna briefly share a story of an asterism because I was just talking about this earlier today with a friend of mine who heard of it. His mom used to show him this constellation when he was a kid. I say constellation. It's an asterism. It's in the bottom of Orion, and it uses Orion's sword. Hold on, can I get it right? Anyway, basically, his mom saw a cow or a bull in it, and so they speak Spanish, and so she called it El Toro. And it's one of my favorite asterisms now because every time I see Orion, I think of El Toro.
Yeah, they're actually, I have a little book that I don't have handy right now that lists asterisms that are visible either binoculars or under high magnification. So it's a little, an open cluster with a certain shape or something like that. So yeah, I encourage everybody to enjoy the night sky. Don't worry about, don't worry about being on too much of a mission that you must see this or that. Just start exploring and you'll pick up things, and then try to generally note where you saw them. And then later on you can go and find out, oh, that was the Messier so-and-so or this and that. And try to make it so you can find them again on another time. Try to make a little note of how you found them. And you'll discover all kinds of things.
Oh, I hope you guys have fun out observing too. It's really fun to be able to discover this sort of stuff. So I definitely encourage you all to go out observing. I will mention as well that we're running a second program every other week, the week's Opposing Insider's Guide, where we are doing observing. And so if anyone wants to try their hand at observing for the first few times, that program is called Explore the Universe. And it follows an observing program that RASC already has. And so if you see a certain number of objects, you can get yourself a pin and a certification to show that you saw things in space. It's a nice project to have. We're running it until October. And you should be able to find enough stuff through that program that you can get the pin. provided you don't have clouds for 6 months straight, fingers crossed. A question quickly from Joe, which was, not a question, an observation that the ISS is visible in Vancouver tonight. And I'm going to make a recommendation given to me by Chris to use the Astrospheric app. I freaking love this app. This app is fantastic. It shows you, oh, it's polarized. There we go. It shows you what the clouds are going to look like, what the weather is going to look like, what the seeing is going to be when the ISS is passing over. There are 5 passes over tonight here and where I am. It shows you the temperature, the dew point, all sorts of great stuff. Fantastic app. Give that one a try if you're interested in that sort of stuff. Thank you, Chris, for pulling it up.
There it is there. This is the Astrospheric app. So yeah, it gives you, at first glance, it's extremely intimidating looking, but really all it is, it's hour by hour. So Thursday, Wednesday, Tuesday, Wednesday, Thursday. The more blue you see, the darker blue, the better, you're happier you are if you're an astronomer. And if you're a gardener, you probably want to see white and green. That means rain and cloud. But we like the dark blue. And here's the rise and set time of the moon. Here's the space station passes.
And it's really helpful once you it's got a lot of information, but it's really helpful for planning out your observing sessions. And you can move the target around to different places to see if the observing is better in one place or another. That helped a friend and coworker of mine and I decide to go observe in one place versus an hour further north. So fantastic app. Excellent recommendation, Chris. And one last question from Heather. Will the session be on YouTube? Yes. All of our sessions are live streamed on YouTube at the same time as we host them. So you can go back and rewatch if you need to. If you missed the first part, make your notes, take your notes. Remember, if you go outside, if you're planning on going to observe in a week, come back and rewatch the episode and see what we talked about. For at least the Explore the Universe ones, we timestamp when we talk about certain targets. We may start doing that on this, we'll see. But either way, they're there. So if you need them, you can always go back and check. And I think
so the moon will be out of the evening sky until it will reappear about Tuesday. Tuesday, Wednesday, it won't be very offensive. It'll set early right after sunset. So it won't bother our comet hunting or our Milky Way exploring. So you've got, almost a week, about a week to explore the dark Milky Way sky, wishing you all clear skies. And as I said, a few weeks after that, the moon will get out of the way again and we can try again in August. So lots of good stuff to chase down.
Lots of good stuff to chase down. My last point that I will make as well, if anyone is brand new to observing and is interested in that Explore the Universe program, we have been running it for 2 weeks already. So we have a special presentation on Thursday with, Robert Conrad. He's the observing chair in Vancouver, and he's going to talk to us a little bit about starting observing and going over some basics again. We've done that lots of times on our YouTube channel, but it's always nice to do it again. So if anyone wants to join in for that as well, that is on Thursday night, 7 p.m. And then we'll be hopping back into Explore the Universe the following week, Thursday at 3:30 p.m. So that's what we got coming up. You can check rask.ca for more information on that stuff, or just subscribe to our YouTube channel and click that subscribe button and hit the bell notification. I'm going to sound really annoying after a while. I'll stop. But we'll see you guys. We'll see you guys in the next couple weeks, and we'll be hosting Insider's Guide again in 2 weeks from now, and we're going to be talking about, I've forgotten. Do you remember, Chris?
That's a rask.ca.
I'm doing the same thing.
It's gonna be
Constellation
Deep Dive. So we're actually going to repeat ourselves a little bit. Maybe we'll find a way to mix it up a little bit.
Yeah, we'll see. Maybe that would be a good one to maybe go over a little bit of the Perseids meteor shower before it happens too.
Yes.
We will see.
We'll
figure it out. Okay, sounds good. We'll see you guys in 2 weeks. Thanks everybody for joining, and we'll see you next time.
Bye now. Keep looking up.
Clear skies. Keep looking up. Have fun and explore.